Hello, everyone. As Adi mentioned, my name is Mark, and I'm from Datastrato, which is the provider of a open source data catalog called Apache Gravitino. You may recognize the Gravitino name because it was actually in the slide deck that Bharath and Akshay presented when they were talking about identities. So it's a pleasure to be here and to fit together some concepts that we've been talking about tonight, because there's a great deal of interchange between some of the concepts that we've been talking about. And specifically, what I want to focus on is the natural tension between allowing data that's both governed and queryable. Any organization that maintains a large data lake or a data estate feels the tension between providing data that's both governed and queryable. Most people that we deal with have a vast data estate in which they're dealing with many, many different data sources and many different data engines. And so wouldn't it be nice in the Nirvana state that all my engines could just talk to all my data, and that I could have one universal way to govern all this data in a consistent way? That's the goal. And in the agentic age, it becomes more imperative than ever, because we can't have data just running all around the organization that's unqueryable and ungoverned. The agentic experience will degrade, and the agent will take care of and take advantage of every opportunity that you provide it to learn anything about anything that you didn't want the agent to know. And so governance of data becomes more critical than ever. What we want to do is to seal the tension between what's governed and what's queryable. And Gravitino was originally created to do just that. Gravitino is a data governance layer on top of a wide variety of data agents. And so you see at the top, we have a governance layer that creates a consistent metadata layer on top of a wide number of data sources. AWS Glue is a feature that we added in 1.3, but we also talked to a variety of other data sources, including one of my favorites, which is Apache Iceberg, which is a great way to create a vast data lake. You can create a data lake on object storage like S3 or your local storage, and it costs pennies to store petabytes of data that you can now query for a wide number of data sets. And so as great as that sounds, and as many problems as that solves, the agentic age now brings in a whole new set of problems. Now, our previous speakers are talking about the semantic problem. And truly, the semantic problem is the next challenge to be solved regarding your data estate. And the reason is because your data agents don't know anything about your data, and you probably don't want them finding out everything about your data. And so this has to be controlled, and the agent has to be directed. There are three primarily new layers that we're introducing. On top of sources and federation that we talked about just a second ago, we now want to talk about identity. Akshay and Bharath did a fantastic job of talking about identity. It's not really a new concept, of course. We've got OAuth, we've got OAuth flows, we've got all that. But in the agentic age, we have to control which identity the agent is using, and to make sure that that identity is always correct and up to date. On top of that, we have governed access. The agent must be controlled in what it has access to. And finally, we have a modeling layer that is meant to encapsulate the details about your data estate that will guide the agent to make the correct decisions about your data. And so it's not really agent reasoning. It's below that, at a point where you're telling the agent more about the data you already have. Now, the typical way this is done is through something called an ontology. And oddly enough, this can be called a knowledge graph as well. You may be from an organization in which you know ontologies backwards and forwards. If you're from almost any financial institution in America, your organization probably has one or more ontologies that represent your data estate. You have a certain number of accounts and customers and transactions, and this is how they relate. I'll tell you a little bit about this, but there are many other organizations that have ontologies, or they are creating them, or you can get a catalog that'll create them for you, which is why it brings us to the present moment, because the ontology tells the agent how your data interrelates and the relationships between it, which is extremely critical to creating queries. And so we'll talk a little bit about how this works. Now, I've got a couple of slides here about MCP, and we've had previous speakers talk about MCP. I probably don't need to spend a great deal of time talking about MCP is my impression. I went to a developer show that Anthropic sponsored in New York a couple of months ago, and the speaker at the beginning of the show said that Anthropic has crossed the download count for MCP developer kits, 100 million a month. So I'm going to assume that most people know about MCP and that we don't have to talk about that. But one of the things that's worth talking about and just emphasizing is that not all MCPs are created equal. MCP is a two-way dialogue between your server and your client. And I've got a slide here that shows how the client offers certain information to the server offers certain information back. And so there's a two-way exchange of information that helps the client to know what MCPs they should call. Gravitino's MCPs have been tuned so that they provide your agent with specific metadata about your data estate, and they help to find metadata. If you ask Trino, tell me where all my tables are, it will tell you in 15 or 20 calls, literally. If you ask Gravitino, it will tell you in one call most of the time. And so there are differences, and the only way I'll leave it tonight is to say there are differences between what MCPs are, and this is something worth knowing. Second of all, I want to talk a little bit about enforcement. Catalogs are all about enforcement because we don't want agents running amok dealing with data from wherever part of the data estate they find it. And the enforcement problem is getting bigger than it ever was before because the catalog is now not the only item that's participating in enforcement. The Iceberg Committee defined this notion initially because they have the idea of fine-grained access control that's implemented through instructions that are passed from your Iceberg catalog down to your engine, like Trino or Spark. When you issue a query, if you have implemented any row filtering or column masking on that table, your catalog will pass to Trino or Spark some instructions that say, you must filter these rows, you must mask these columns. And the idea that seals this is the idea of a trusted engine. A trusted engine is one that has certified that they will obey the rules that have been given it. That's how the Iceberg Committee is planning to implement row filtering and column masking in an Iceberg data lake. And similarly, we've taken and extended that idea to the point of using an OPA engine. If you've never heard of OPA before, it stands for Open Policy Agent. It's a agentic platform that's already built into Trino, and it provides the ability to install rules that will be obeyed by your Trino at the point a query is executed. That allows you to define row filters and column masks on any data set in your estate. And the masks or filters are performed by your Trino at the point the query is executed. And so, wow, what a fantastic thing that we can transport rules from your catalog down to your data estate, like your Trino or Spark, and have them honored there. Now, the way this works is that you have policy changes from your catalog that move through a compile state and then are published into a bundle that is installed in your Trino. And I would be delighted to show you that on another occasion. We've already talked a lot about identity. And so I'm very tempted to point to the great work that Akshay and Bharath have already done, where they pointed to the need to have every agent with an identity. And in many cases, it's the agent's identity, but it's also your identity, because the agent really on its own shouldn't have the ability to access anything. The agent has to work on behalf of another user. That user is you or whoever logs into the agent. And so there is a formal RFC that dictates the token exchange policy that needs to occur for an agent to assume the identity of a user whose behalf it's operating under. And I encourage you to take a look at this if you haven't, but if you're not familiar with OBO or your agent is currently operating with no identity or with some kind of mixed identity, this would be a big step forward because the agent's identity will determine in a governed environment what it has access to. Now, the final step in the modeling stage at the top of the previous picture that I showed concerns this idea of an ontology, and I want to talk a little bit about that. Think of a knowledge graph or a bubble diagram where you have concepts that represent meaning in your organization. If you're a bank, you've got accounts and customers and transactions, and there's a relationship between them. I'm familiar with someone who works in the heating and building infrastructure industry, and they have an ontology that says, I have a building, and in the building I have a certain number of floors, and each floor I have a zone, and every zone has a thermostat and everything. And so you can see how these represent concepts that are important in your data and in your pursuit. You have relationships between them. And these are very, very formal, yet very simple concepts that translate to any number of industries. And so you have this ontology here, which is a triple. It's a subject, a predicate, and an object. And this is so simple. You would think, Oh, well, how much good can this do? This can do an incredible amount of good because I can create a knowledge graph with just these three cascaded down through a series. Once I have this series, I can give that to my agent, and the agent can ascertain important relationships in my data. Now, I can give that ontology to the catalog or even to the agent itself in several different forms. But those triples that I talked about a second ago are instantiated in several different files. There's something called a turtle file, well known. How many people have ever dealt with turtle files? Okay, one, two. Very good. Okay. So you can see here, TTL file is a representation of triples, sometimes a vast number of triples. And if you don't have a turtle file, you can have something equivalent called a JSON LD file, which is a JSON representation of the same concept. There are open source readers for ontologies. There are going to be an increasing number of catalogs in your data estate that know about ontologies. Why? Because once the agent or the catalog knows about your ontology, they know a vast amount about how the data in your environment interrelates. That information can be used by the agent to answer natural language queries far more accurately than it ever has before. You can ask the agent, which account had a transaction? Is this in the, well, let's see now. I can see that I have to cross this and this and join this and this in order to get that. The ontology told me all that. And so regardless of the query, for a wide number of queries, the ontology is the place where the agent wants to start. And from the concepts, it will translate those to the tables in your estate and down to the governance, which is the catalog's responsibility. We have something called OWL, which is an enhancement to your turtle file that provides additional decoration for the classes in your turtle file in order to provide linkages. And so you can see here that I could have various properties on various concepts. So what have I got? I've got a whole zoo. I called it a zoo because I've got turtles and I've got owls and I've got sparrows and I've got a variety of things. And so one may think, oh, this is overly formal. This is overdone. This is entirely complex. But actually, it's amazingly powerful. And it will be something that you may want to learn more about its power in your organization to either transform the data you're already using, or maybe your organization is already using these. Catalogs such as ours are very busy creating support for ontologies and the way agents will start with them in your semantic environment. This is how an agent would use this information. I'm going to start with your ontology in something like customer or tax ID, and your OWL is going to tell me how to get to a governed object, like a table. And once I get to a table, I have a set of enforcement that you have provided regarding who are the identities who can have access to that object. So we have closed the loop in terms of what your important concepts are, how they translate to data in your estate, and who can have access to it. Hence the importance of identity. And so, wow, your agent is not only incredibly powerful, but also incredibly limited. Now let's put it all together and let me show you how this works. I'm going to ask in plain English of the question of the agent, who's going to investigate metadata through a powerful MCP. If they don't have an ontology, they may just do a governed read directly from Trino and its affiliated OPA query engine, which is going to have the rule base associated with what the agent can see. Then we may rerun as another user if I have the ability to assume another user, or I may start with the ontology and start with a completely different query. That's sort of the future that we imagine that makes your data estate both governed and queryable. Now, if any of these concepts sound interesting to you, we're very busy writing this stuff right now in a release of the catalog that's going to be available soon. And so if any of that appeals to you, or you're doing any of that, or would like to try any of this stuff, I'd love to talk to you more. Any questions I can answer?
Do you use SparkQL to interact with Gravitino?
That's something that we're investigating. In other words, that's the language to query an ontology. And that can be one avenue, yes. What's more probable is that your agent or your catalog will present the ontology in several different MCPs so that the agent can learn the ontology and then follow the relationships. So there's a couple of different avenues.
So what language does Gravitino use to interact? Like, how do you interact with Gravitino? Like any coding language or any?
There's a set of REST calls. Because your agent is what does most of the interaction through MCP, or your engine through REST.
Mark, that was a fantastic talk.
Thank you.
have rarely seen somebody cover so much ground so effectively. And I'm curious, how do you think about, there was a question about entity resolution when we were talking about RunLog AI. I mean, I could ask you about entity resolution, but I'm not sure I care as much as I think about a controlled vocabulary, synonyms, glossary. These are a few terms you didn't explain elegantly. And I'd just love to hear what you have to say about that.
Due to time, there are definitely additional concepts that I could have gone into.
Yeah.
You mentioned a glossary, which is typically the way to add structured content to the description of a concept in your ontology. And so it's another item that you would provide through MCP to your agent, because the agent will not only see the concept, but then it'll see the glossary and it will have additional information about what it is that it's dealing with in a concept. And so there are several different ways to think about the difference with agent structuring, agent reasoning algorithms and an ontology. And one of the, I think, best ways is to see that in an ontology, you have a formal and reproducible way to understand the inalienable facts of your data estate and your business. Now, a bank, as an example, is an extreme case because it's very formal and it's very regulated and it's very structured. But that means it's a good example of the kind of thing I'm talking about, in that I have certain things, accounts and transactions and this and that are a part of my organization and reflected in my data. And I need to make sure the agent understands that. And I need to make sure that its behavior always follows the rules that I have for the use of my data. So I don't need agents to reason about extremely wide open. I need it to follow these concepts and rules. And an ontology is the way that's done, because you formalize to the agent the representation between your data, and then it has the guidance that it needs.
But does Gravitino provide that access to the ontology through the MCP server when the agent says, give me customer 73's old account related to thing?
Yes, sir. That's exactly what I'm saying, is that we're in the process of building this.
Okay.
And
Very
so
cool.
if this is interesting to you, I'd love to talk to you more about it. My assertion here, and what makes this not just a blatant commercial pitch, is that you'll find many catalogs that are moving in this direction. And so this is a set of terms and vocabulary that, regardless of the catalog you use, you may use Unity Catalog, you may use Databricks, you may use Snowflake, you may use Google Thing, whatever it is. You'll find these concepts in greater and greater use throughout the industry. And just to give you an example, I just read something where Databricks said that they are going to start supporting and creating ontologies based on your query patterns. And so it's a well-known, and as you can see, defined science in which I have so much known about how an ontology should be created, structured, defined, and agents will be there ready to use that information because they know what an ontology is. Does that help?
Do you have somewhere for people to go when they want to get started?
Well, I think the best way is that at the end of my pitch, let's go to the end here again. I'm sorry, I'm going the wrong way. At the end of my pitch, I've got, thanks to Adi, these codes, and I would love to tell you more or talk about any use case you have in mind or get you started. Yes, sir. Did you have a question?
Yeah. So, well, I kind of like have a similar question, but it's more or less like, let's just say I have my own Neo4j database and it has like its own ontologies, but it definitely has that triplets that you talked about, a connection and to create a graph out of it, right? Is there any way, or do you see kind of like a metadata creation where I can like convert my existing data or my own?
Let's say that there will be many ways to do so, because there are an abundance of ontology creating tools, including Apache open source tools. I have received ontologies from people, and I wrote a Python script to read the ontology. It's a triple. So it's insanely structured, and that makes your Python script insanely simple. And it makes it very, very easy to spit out ontology stuff. And so let's suppose that you've got a bunch of random information in a bunch of random ways. You may not have the structure of a triple all the way through to provide a complete linked set of concepts and the relationships between them. but there will be tools to do so. Or if you just want to invest a little time and think, okay, this has this, each has one of these, you can formalize it into an ontology and get it into its proper form very easily.
And probably just, I was about to say what you said about like scraping or creating a script for that. A lot of, I would say, people are now moving towards pydantic structure databases. And then if they want to, like, let's just say, create something that supports Gravitino, they can, just export that kind of their module or their data classes into here. And Gravitino basically imports it and creates an ontology based on whatever they have done.
That's right. That's exactly right. And I would say that regardless of the data catalog that any of you are using, if it provides specific requirements for your ontology, then something's wrong, because ontologies are meant to be insanely portable. Turtle files and JSON LD files, and these are all well-defined concepts that allow your ontology to move, and that's what you want.
Makes sense. Yeah, thank you.
Any other questions for Mark? Cool. Thanks, Mark.
Thank you very much.